Well, good morning, everyone. Welcome to the National Biodiesel Conference and Expo. Thrilled to have you here in sunny San Diego with us today. My name is Shelby Neal. I serve as Director of State Governmental Affairs for the National Biodiesel Board. Just one house cleaning item before we jump into the content section. So this year, to help encourage people to sign up for Biodiesel Connect, that's our app that lets you connect with anybody in the conference. You meet somebody and you have their name, but you forgot their email or something. You can find them through this. It's really handy. If you sign up for that, or you are already signed up for that, at the end of this session, we'll give out an Amazon Smile gift card. So usually giveaways are not the absolute best gifts, but in this case, it's actually a really good gift. It's either a $50 or $100 gift card to Amazon.com. So if you are not already signed up for Biodiesel Connect, the address is connect.biodieselconference.org, connect.biodieselconference.org. And don't worry, we're not going to spam you or anything. Well, actually, we already have your information and plan to spam you, but you won't be spammed as a result of signing up for this. So again, connect.biodieselconference.org. So thank you for coming to this session, Renewable Hydrocarbon Diesel, the Basics. For those of you who went to the general session, you saw a great, or at least in my opinion, a great video to start off with Kenlyn Johannes from the Kansas Soybean Association. And Kenlyn was in the truck, and one of the things I noticed is that he picked up a set of keys, and it said National Soy Biodiesel Association. I don't know if anybody else, because I haven't seen that in a long time. And so the theme, of course, was that we're evolving, we're continuing to grow, we're expanding. And so I thought this session was really good tie into that. Of course, we started as the National Soy Biodiesel Association, but then fairly shortly after that became feedstock neutral and adopted all feedstocks. And the industry's grown significantly, supported by all of the feedstocks. But then 2.5 years ago, we had another significant development at the NBB. We haven't changed our name. We're still the National Biodiesel Board, but we did adopt renewable hydrocarbon diesel as a component of our membership. So the two commercial RHD producers in the country are members of the National Biodiesel Board. We're very proud to have them. One of them, of course, is RAG, which also has is also the largest biodiesel producer in the country. The other is Diamond Green Diesel, which I think at the end of next year will be about 300 million gallons of capacity. So both very substantial producers and great additions to the National Biodiesel Board. As staff, sometimes we come up with these sessions, sometimes they're ideas from our membership, but we kind of had an epiphany that we have a Biodiesel 101 session every year, and we've never had an RHD 101 session, and so this is the first one of those. When we adopted RHD 2.5 years ago, frankly, we didn't do a lot of communication around that and help educate people about what RHD is, how it differs from biodiesel, how these are complementary products, and how this furthers really the mission of the organization and everyone who's involved with the NBB. So this is kind of our first shot at this, and we hope you'll give us lots of feedback and ask questions. I'm thrilled that Dave Slade has agreed to speak. He's probably slightly less thrilled because he's been working on this presentation on weekends. Oh, he is thrilled. That's great. So Dave, I think, is really the perfect person. He has an extensive technical background, really impeccable, frankly, and he's from RAG. RAG is uniquely qualified to provide an even-handed discussion about this topic, as they have both substantial biodiesel interests and substantial RHD interests. So let me tell you a little bit about Dave, and then he'll take it away from there. So as Executive Director of Biofuel Technology and Services, Dave Slade focuses on technical issues throughout Renewable Energy Group's biofuel production and distribution network. Dave leads RAG's technical services team, which works to improve production quality and efficiency at the company's production facilities and provides technical support to petroleum companies, engine manufacturers, transportation fleets, and government agencies as they incorporate biodiesel and renewable hydrocarbon diesel into their fuel programs. Dave holds a master's degree in chemical engineering from UC Davis and a PhD in chemical engineering from the University of Kansas, a liberal arts school in Lawrence, Kansas. Go Tigers. So thank you to Dave for being here. It really is an honor. So Dave has about 30 minutes, I think, of content, and then we'll plan for an extensive Q&A session afterward, and then once the Q&A session's over, we'll hand out the either $50 or $100 gift card. Thank you.
All right, thank you, Shelby, and thank you, everybody, for being here. I was thrilled to talk about this topic because I've had versions of this conversation, I don't know how many times, so this finally forced us to get it all down in PowerPoint form. So you're the guinea pigs for this particular presentation. I will warn you, I threw a lot of chemistry in there for the non-chemists. It'll seem like a lot of chemistry. For the chemistry people, it'll seem like a very rudimentary set of chemistry things. But the reason I did is because I think it's really important to look at the molecules involved, and hopefully you all come away with a pretty good fundamental understanding of the differences between these two products, between biodiesel and renewable hydrocarbon diesel. So some real quick information about REG specifically. Our focus right now, our mission, you could say, is to enable a cleaner world through lower carbon intensity products and services. So we're really focusing on pointing out the carbon intensity of our products, as I'm sure all the other producers in the room are. We do have 11 plants in operation, biomass-based diesel plants, a total of 452 million gallons per year of nameplate capacity, which does make us the largest biomass-based diesel producer in North America. You can see there are also 4 more plants down there at the bottom of this slide that are not currently in operation. They're under construction, so potentially up to 15 plants. And then one of those is a fermentation facility, which is a new technology for us in Okeechobee, Florida. It's kind of a pilot scale plant. We have production and distribution nationwide, so you can see the greens are production facilities, blues are terminals where we distribute material, and the yellows are the plants that are incomplete. So we are a nationwide company and a global company in that regard as well. We have a couple of plants that we own a significant majority of in Germany, so we do have international production and distribution now as well. This is a photograph of the renewable hydrocarbon diesel plant in Geismar, Louisiana. This is our REG Geismar plant. I think it's worth looking at the picture. Those of you who've been in a conventional biodiesel plant can see right off the bat that it's a little bit different. It's very similar to petroleum processing, and I'll get into the details of how this works, and you'll see why. But it is a little bit different in that regard, so a little bit different environment, a little bit different set of things to take care of. The plant's nameplate capacity is 75 million gallons per year. That's of all fuel products, and I'll explain what that means here in a couple slides. And it is we call it a feedstock flexible plant, or it can use both high and low free fatty acid feedstocks, crude or refined. So jumping right into a bit of vocabulary. There's some words that we use in the RHD industry that we don't normally hear in the biodiesel industry. First one, and this is actually an important word for fuels in general because hydrocarbon has been incorporated into the ASTM standard for diesel fuel. So ASTM D975 recently clarified that diesel fuels are hydrocarbon oils. And what that means is they're made up of molecules that consist only of carbon and hydrogen. Biodiesel is different. Biodiesel has oxygen in it. It's an oxygenate. So biodiesel or methyl esters would not actually be a hydrocarbon from that perspective. Hydrotreating is another very important word for making renewable hydrocarbon diesel. The way you get the atoms other than carbon and hydrogen out of a molecule is typically by hydrotreating. So we use hydrogen to remove non-carbon or non-hydrogen atoms. And I noticed a lot of you still trickling in. There are some prime seats right up front here, and I will not be offended if you want to walk up there. I felt bad for those of you on this side of the room because the only screen's over here. So don't feel bad about just moving over because I'm going to get to some pictures here in a minute that might be a little bit hard to see from that side. So we hydrotreat molecules to make them hydrocarbons. Think of it that way. There's a side effect, and it's a beneficial side effect. Also, when you hydrotreat molecules, you can remove double bonds. The chemical term for that is saturating or saturation. So you turn an unsaturated molecule into a saturated molecule. I have a picture there that can show you what that looks like. Then the final step, after you've made a bunch of saturated hydrocarbons, very good materials, they burn great. The problem is the melting point is pretty high. Okay, you've heard paraffins. Most people hear the word paraffin, they think of candle wax, so something like that. So then the last step for making a good saleable fungible RHD product is to isomerize the molecules, and that has the effect of lowering the freezing point to the melting point. So it does that by rearranging the atoms in the molecule. It doesn't actually add or take away any atoms. That's the distinction between isomerizing and hydrotreating, for example. So just keep that in mind. You'll hear these words: hydrocarbons, hydrotreating, isomerization. And now, the products. When we make biodiesel, everyone I hope in the room is aware, you make your esters, your methyl esters, or your ethyl esters, and then you have a glycerin co-product typically. The glycerin co-product is not in and of itself a great fuel. When you make RHD, all of your co-products are fuel products. So we make the RHD, which is the target product, the diesel cut. We also get a naphtha cut, which is a gasoline blend stock, 100% renewable hydrocarbon gasoline blend stock. And then we get LPG, which is really mostly propane. So think propane for that LPG product. So you get 3 products out of an RHD plant. They're all fuel products. Okay, now we're going to get back to, this is a quick intro slide just to show you the difference between biodiesel and renewable diesel. And I'm going to move over here so I can point. Check, check. All right. Let me get on. That was loud before. How we doing? Nothing? Check, check. Yeah. Turn it off. Okay. Now I should be on in a second. No? Check, 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 check. You want to try that one? Thank you. Check, check, check. That sounds more like it. Almost. Just a little more. All right. I'll just stand here. All right. Back to the mic. They worked before. You want to? Maybe you can get it going. All right. So think of making biodiesel. We start with triglycerides, which have 3 fatty acids connected by a glycerin group. We react with an alcohol, methanol. We end up making 3 methyl esters and a glycerin molecule. So hopefully this is relatively familiar to everybody. Okay, that's biodiesel. We call that reaction transesterification. We start with 2 raw materials. We end up with 2 product-type molecules. So making renewable hydrocarbon diesel, we start with the same molecules, same feedstocks. In this case, we can use a triglyceride as our example. Instead of adding an alcohol now, we're adding hydrogen. We're using hydrogen to react with this. This is the hydrotreating process that I mentioned. Did you get it? What you get then when you hydrotreat these molecules, the 3 fatty acids turn into hydrocarbons, or paraffins, strictly speaking, is the fancy chemical word for that, and you get a propane molecule instead of a glycerin, or glycerol, and I'll show that slide here in a sec, but just keep that in mind. We are starting with the same feedstocks. We're getting 3 molecules of a fuel, but then instead of glycerol, we're getting another fuel molecule. 1 or 2? I don't care. 1. Check, check, check. So here's a nice fancy chemistry drawing. These are called ball and stick drawings. So in this case, the little balls that you can see, the spheres, are atoms, and the sticks are bonds, just showing that they're bonded together. So what you have, if my pointer will, kind of a tough angle. So you get 3 molecules of hydrogen. That sounds like it's hot. Okay. Free at last. All right, so what we have are 3 molecules of hydrogen can react with this glycerol portion of the triglyceride, 3 oxygens. That's what makes glycerol interesting, is it's a 3 oxygen containing alcohol. And the hydrogens come in and react with oxygen, and hopefully everybody in the room knows if you have 2 hydrogens and 1 oxygen, you know what that is. The non-chemist should even know this. You get H2O, right? Water. So you remove oxygens using hydrogen and make water. So then that glycerol, instead of being glycerol, becomes propane. Propane is a 3-carbon hydrocarbon. So far so good, right? Now, a couple of the pictures just to give you a feel for what I'm about to show next. So these are a little bit different kind of drawing. This is called a space-filling molecule, so I apologize for the mix-up there if it's confusing to anybody, but you can see oxygens are still red, the gray things in here are carbons, and the white are still hydrogens. So these would be 2 different types of triglycerides. If they're saturated fat, they look like that. They're linear. If they are unsaturated, they have a bend in them. Basically what that does is lowers the melting point. So this is why unsaturated fats and oils are liquid at room temperature, and saturated fats and oils are solid at room temperature. So that's the starting material, three fatty acids stuck to a glycerin group right here with the oxygens. All right, so now, hydrotreating number 2. So I showed you what happens to the glycerol when you hydrotreat it. Here's what happens to the fatty acids when we hydrotreat it. Hydrogens come in, react with the oxygens to make water. They also react with this double bond. This is what makes it an unsaturated fatty acid. React with the double bond to make it saturated. You can't really tell probably, but there's 2 hydrogens there, and there's 4 across there. So you basically add that hydrogen to that. And then one last hydrogen is needed to saturate up that last carbon. So we react fatty acids with hydrogen to make hydrocarbons or paraffins. In this case, this is called an N-paraffin because it's a straight chain. All right, so quick review so far. Hopefully it's all staying pretty clear. Renewable hydrocarbon diesel versus biodiesel. Both of them start with fats and oils, triglycerides. Saturated fats tend to be more prevalent in animal fat. Unsaturated fats tend to be more prevalent in veg oils. React with hydrogen to make a paraffin. React with an alcohol, methanol, to make FAME, or fatty acid methyl esters. The important thing here to keep in mind, these actually both are very similar in their size. This has oxygen. So biodiesel, or FAME, is an oxygenate. That gives it some of its beneficial properties. That's not a bad thing per se. Paraffins are not oxygenates, they are hydrocarbons. So we hydrotreat to take the oxygen out or turn oxygenates into hydrocarbons. Those are the first 2 words we had in our vocabulary section here. All right, biodiesel meets ASTM D6751, or it should. Hopefully it does. Paraffins are already constituents of diesel fuels, so RHD, if it's made properly and is good quality, meets the diesel fuel spec, D975. Okay, the diesel fuel spec I mentioned at the very beginning has a new provision in it that requires diesel fuel to be a hydrocarbon oil. That's a new addition in the last couple years. So people that want to blend other things into diesel fuel and call it diesel fuel, if they are not hydrocarbons, they are not following the rules. So keep that in mind. There are lots of things being blended into diesel fuel nowadays that don't actually conform to D975. Likewise, if someone sells a biodiesel product that doesn't meet D6751, that doesn't conform either. So that's another problem. Oops. All right, so one last word, our vocabulary, isomerization. So when you hydrotreat a fatty acid, you get this nice long C18 paraffin. I mentioned it's a straight chain. It's called an N-paraffin. That's fancy chemistry talk there. This one has 18 carbons and 38 hydrogens. Okay? The last step in making renewable hydrocarbon diesel that's fungible and usable by everybody is to isomerize it to lower the melting point or lower the cloud point. So we do an isomerization reaction. It's a little bit hard to see here, but you can see this is now branched. This has a little Y there, and the same thing over here. It's the way that you do these molecules. That's what I get for using the internet. But there's a branch here too, another Y. So by adding 2 branches to that molecule, you lower the cloud point by about 40 degrees Celsius, about 75 degrees Fahrenheit. So it goes from being a solid at room temperature to a liquid down to about 15 degrees Fahrenheit, which is pipeline diesel spec. But notice it's still C18H38, still has 18 carbons and 38 hydrogens. We did not actually change the composition, we just changed the structure of the molecule. That's what isomerization is. So if nothing else, you can always go home and show off to your significant other or your children that you've learned a new word here, isomerization, changing the molecule without changing the number of atoms involved. So that is the last step. And then if you really want to show off, you can use octadecane and dimethylhexadecane, but those are the 2 different names for those materials. All right, so this is what it looks like. We start with oil or fat. Notice the lovely dark color of this because this would be what we would call a high free fatty acid feedstock or a low-cost free fatty acid or low-cost feedstock. We hydrotreat it to make a paraffin, which is actually a beautiful clean hydrocarbon, but probably not fungible in diesel fuel since it's solid at room temperature. And then we isomerize it to make something that's even more attractive and more desirable. And these molecules have the same number of carbons as these. They just have been restructured to lower the melting point or the freezing point. So that's it. That is the entire technology for making a nice on-spec renewable hydrocarbon diesel product. Nice summary slide here, and these are not necessarily in order, so don't look at these pictures and think they represent each of these steps. But remember, we have to pre-treat because we like to buy the lowest cost feedstocks we can, so we have to clean them up. Then we hydrotreat them to convert the triglycerides or the fatty acids into hydrocarbons. We then isomerize that to lower the diesel cloud point. And finally, we have to split that hydrocarbon stream into the three products. And as I mentioned right off the bat, we have three products. We get the diesel cut, we get the naphtha cut, which is a gasoline boiling point range material, and we get the LPG, which is mostly propane. And the propane comes from the glycerin portion of the triglyceride. So really, there's no way around making that propane product. All right, we're almost done. This is small, don't try to read this. I just wanted to show you. This is the ASTM D975 specification. So our product, our diesel product, meets, we have the same limits as D975. There we go. Okay. With the following, I think we lost our, following exceptions. All the rest of them are the same. Copper corrosion, it's a cleaner material, so it's a lower corrosivity. Sulfur is effectively 0, but we'll call it 2 max. Aromatics, there really are very few aromatics. We'll call that 2 max. Cetane is the big improvement. So when you do this to fats and oils, you make these paraffinic and isoparaffinic fuel mixtures, you get really high cetane. It could be as high as 80 cetane. It could be above 80 cetane. We call a limit of 65 minimum because we don't want to go under our limit, but consistently it's in the mid-70s or higher. So think of this as a very high cetane, very clean burning, very high quality diesel material. And then the cloud point, because of the isomerization, we have negative 10 Celsius or lower, which, as I mentioned earlier, is the diesel winter pipeline spec. So the several pipelines, they're not all exactly harmonized, but they're roughly negative 10 Celsius in the wintertime. In the summertime, that goes up. So we're running negative 10 or lower on the cloud point. So in that regard, you can see a little bit of an advantage over conventional biodiesel, where negative 10 would be a unattainably low cloud point for most biodiesels. All right, so the benefits then. We've made this product. We've done it at a plant that doesn't look anything like a biodiesel plant other than we get the same kind of feedstocks. And now we have a product that's ready to sell. It is a very low emissions product, and that's largely because of the high cetane and the clean nature of the fuel. The lack of aromatics and the lack of sulfur give it a very low emissions profile, very clean burning. The cetane, as I mentioned, is typically above 75. Very low sulfur, call it extremely low sulfur. Cloud point looks great. It is pipeline approved across the board, up to 5%, and certain pipelines in certain circumstances will ship higher blends. Really, there's no important technical restriction there. It's just it's a new product, and the pipelines are by nature very conservative, and we all appreciate that. And so it'll take a little while, but it is pipeline approved already, up to 5% in any pipe. And it can be blended at any level. So most important, I think, here is that this is just another component, another diesel fuel. It can be blended with petroleum diesel. It could be blended with biodiesel. It can be used as anything to lower your carbon intensity, to improve your emissions, to give a more renewable fuel supply. So just to show a quick emissions slide, now these are B100 in blue, R100 in yellow, and a mixture, just for fun, of 20% biodiesel and 80% RHD in gray. So you can see that the biodiesel, and this is the baseline for this, the 0 point is conventional ULSD, not carb diesel, but conventional ULSD. B100 versus conventional, R100 versus conventional, and then a blend of the two. So obviously we've heard for years, and we're all familiar, that biodiesel has very low hydrocarbons, particulate matter, and carbon monoxide emissions. Renewable is a little less of an increase on those because it is a hydrocarbon. So biodiesel is lucky in the sense that we get to have very low hydrocarbon emissions because it's not a hydrocarbon. But the blends have a nice intermediate value, and I didn't show it on here, but one of the major advantages for RHD is that it is actually a NOx-reducing fuel additive. So it, by itself, straight RHD has significantly lower NOx output in a non-mitigated engine exhaust system than diesel fuel. So there is an advantage. This NOx, a B20 blend would already be considered NOx neutral by those of us in the room. A B20 with RHD could actually be a bit of a NOx decrease compared to conventional diesel and carb diesel. So clean burning, hydrocarbon fuel, blends well and plays well with biodiesel and does great with petroleum diesel. So applications for renewable diesel that you can consider, renewable hydrocarbon diesel I should say, is that it has great emissions profiles, especially if you consider NOx. It can therefore be used in a lot of areas where there may be a biodiesel blending limit, where people don't want to just run a B80 or a B100. You could include renewable diesel in your mix to improve air quality emissions. It is approved for use in marine fuel. Marine fuel has some restrictions right now on FAME that are being worked on, but renewable hydrocarbon diesel does not. It's a lot more flexible use in the military sector because of that, so a lot of defense applications are considering this because it's a little bit more fungible across their wide range of equipment and doesn't have some of the concerns they have had historically. And then finally, it is a low-carbon fuel option for aircraft. Renewable hydrocarbon diesel can be produced to meet the jet fuel spec and be used directly. It also can be blended in. In the future, we anticipate people will be blending it in the future at lower levels as a blend component. So it is not restricted in aircraft the same way that FAME or biodiesel is. It's not currently open door, but the airlines and the OEMs are working on that. So that's the kind of applications you can expect. And if I can get it to stop. And then a little plug for REG. So we're here to help with anything you can think of that we can provide fuel for. We have our biodiesel offerings, our renewable hydrocarbon diesel. We have the naphtha, which is that gasoline blend stock, which is certainly available for sale. We have LPG, renewable LPG available. We also have an energy services group that markets blended fuels, so ultra-low sulfur diesel, heating oil, and any blended fuels that you're interested in. So don't think of us as just a renewable fuel seller. We actually have the ability to blend and sell all types of petroleum and non-petroleum fuels. I think that's my last slide. Yep, so my contact information. Email is probably the best way to get me, but feel free to try the phone. And connect with REG in other ways. So we have a website on top, Facebook page, Twitter feed, LinkedIn, and YouTube. And lots of interesting videos on the YouTube channel. If you're curious about various topics, including renewable hydrocarbon diesel, feel free to access those and contact us with any questions, and don't hesitate to contact us with any opportunities. So thank you all.
Well, thanks, Dave. That was a great intro to RHD. And so we designed this session to just kind of provide the basics and then allow time for Q&A. So we have 15 minutes left in the session for Q&A. However, if you have other engagements, please feel free to leave. No one will be offended. Doug, you want to go first?
Hi, Doug Hooper, Advanced Biofuels Canada. Question about the interplay between biodiesel and RHD. Are there synergistic benefits to blending the two, or does it go the other way, and do they interfere with each other in some respect? And if there are complementary aspects, what do the ratios look like? What's the science say?
Good question. So synergies or antagonistic effects with biodiesel and renewable hydrocarbon diesel. Generally speaking, they do great together. Renewable hydrocarbon diesel is a very clean-burning, high-cetane fuel. One of the downsides is it has low lubricity. So, of course, to meet the diesel spec, we have to add lubricity additive at the plant. However, as you all know, biodiesel has excellent lubricity, and so blending the two of them together gives you that lubricity benefit. If I can go back to the emissions slides, you can actually see there are some improvements over the gold. So you can get better emissions with a blend of the two in some circumstances. And as I mentioned, the RHD is actually a NOx negative fuel. So from a NOx standpoint, blending the two helps give you a NOx negative blended fuel. You can get 100% renewable fuel that way with optimum emissions, optimum performance characteristics. The lubricity and also the conductivity requirements are easier to meet with a blend of biodiesel and renewable diesel. So I think generally speaking, technically, it's a great blended fuel. The only cautionary note, and this applies to all biodiesel, is that you would want to make sure that your biodiesel is of sufficiently high quality. We want biodiesel to be of high quality before we blend it with petroleum fuel also. So this isn't necessarily a greater sensitivity, but blending it with renewable diesel, it is a highly paraffinic fuel. It doesn't have the aromatics. So it is something to be careful of, that we would encourage anybody to use the best quality biodiesel they can get, regardless of the application. but in particular, if you're going to be blending it with no petroleum component, just the two renewable fuels that you'd want a good high-quality biodiesel. And I can explain more later if you want.
Before we go to the next question, I also wanted to acknowledge Scott Fenwick. Scott, could you raise your hand? Scott's NBB's technical director, so if you see him floating around the conference and have questions about RHD or any other form of renewable diesel, he'd be happy to answer those too. So maybe we could start with the gentleman in the front and then the gentleman in the back, please.
Oh, he was first.
Go ahead.
I just wanted to know if you could share some reaction parameters as far as how this thing works, like temperatures, pressures, like how
Well,
RHD works.
So I probably can't give you what you would like to hear. I can say that we do have a patented and trademarked process that we use at our facility, and so that is available if you're interested in talking about a potential plant. We would certainly be happy to talk to you about that. It is something that we can and would be willing to consider licensing. Generally speaking, it's much higher temperature and much higher pressure than a biodiesel plant. You know, we react biodiesel, we do transesterification at temperatures where methanol is liquid usually. Some processes are higher pressure and higher temperature. These have to be done under situations where we have a lot of hydrogen, so the pressure is much higher, temperature is much higher. The reaction times are typically shorter because it's a high temperature, high pressure reaction. But it is, I will caution everybody, you can't just take your biodiesel plant and turn it into an RHD plant. It's a very different kind of process. And typically the catalysts are solid catalysts. So there's that whole thing as well.
Okay, thank you.
Sure.
Hi. What are the important specs for your feedstock? For the biodiesel, very low FFA is a good quality feedstock. For you, it doesn't really matter. So what are the parameters that you're looking for specifically on UCO? Because that's
Yeah,
what
so,
I'm here.
well, I'll just use this slide as an example. So that's a good point. With biodiesel, a conventional, old school, first generation biodiesel process would like a very low free fatty acid feedstock, meaning a feedstock with low FFA. And if the feedstock is not low FFA, your typical plant would have a process for reducing the free fatty acids. Making renewable hydrocarbon diesel, the FFA can be converted directly to the target molecule in the same reactor and the same conditions as the triglycerides. I showed this slide, whoops. So there's a triglyceride, right? And there's your FFA, your free fatty acid. So we can convert the FFA directly to the same exact paraffin we would convert the triglyceride to. So in that regard, free fatty acids become much less of a concern. Yeah, really the important part, as with any process, is to take out the other impurities. You know, water cannot be converted into fuel no matter what you do, right? Solids cannot be converted into fuel. We don't like to have a lot of heterogeneity in the feedstock. So as with all of our biodiesel plants, one of the primary importance areas we focus on of primary importance is what we call pretreatment, or refining the incoming feedstocks. The big difference with the renewable hydrocarbon diesel plant is we don't need to worry about taking out the free fatty acids. Is that what you're looking for?
Yeah, but I understand chlorides are a problem also, and I'm trying to
So to
make my feedstock good for you.
So to answer that, we can definitely talk after the meeting, but generally speaking, as I mentioned to the previous gentleman, temperatures and pressures are much higher, different kind of reaction, different kind of catalyst. So what we would call non-carbon, non-hydrogen, non-oxygen atoms can have different impacts than they would in a biodiesel plant. So it doesn't mean nothing has to be zero, but various things have to be controlled, either on the side of the feedstock supplier or after we purchase it, we have to control it in our hands. So it is sensitive in that regard to different things, I think, than a traditional biodiesel plant is. But it's less sensitive to other things, like FFA.
Why don't we start in the front again?
Okay.
As you were mentioning the synergy between biodiesel and this fuel in the point of lubricity, I was wondering, is there also a synergy maybe on the cloud point?
So,
Potential synergy, blending these two to get...
like a eutectic or an extra low melting point?
Not exactly that, but at least to move the biodiesel cloud point
Oh, sure.
in the desired direction.
Sure. So that's a good point. If you look at the renewable hydrocarbon diesel as having a cloud point of -10 to maybe -20 Celsius, It does then, of course, give you an intermediate cloud point between the biodiesel and the renewable hydrocarbon diesel.
And
So
is it more or less linear depending
it's
on the blending
linear
level?
is good enough
Is there
for
any data
estimation.
already?
it's not perfectly linear, but it's good enough to estimate. Yeah. So by that question, you can estimate the cloud point of the finished fuel based on the cloud points of the two starting materials.
Two questions for you, Dave. One, what is the split? How much propane, how much diesel, how much naphtha do you get out of this process?
So the actual details, of course, I can't tell you without having to kill
Or is
you,
it
and I don't want to do
one
that. so.
propane, 3 diesel, 2 naphtha type?
Yeah, so if we get
operation?
back to the molecules, as I said, if you're feeding it triglycerides, we are always going to get propane. And you can do the math on that, the weight of glycerin, as a matter of fact, we'll go all the way back. Right? You lose a little bit of mass making glycerol into propane, but you could do the math on that. So you get that much propane. After that, how much of the naphtha cut versus the diesel cut is an operational parameter. Every producer is probably going to have a different split, so I can't share what those are. But I can generally say that right now, under current market situations, the diesel component is a more valuable product than the naphtha product. That may change in the future. And if that happened, we could operate differently to make more of one or more of the other.
So it's definitely an economic decision.
It is an economic decision, definitely. That's correct, yeah.
One other question, the naphtha, is that available in pipe, or are you putting that out by rail?
Right now, it has to be shipped by truck or rail, yes.
Okay.
And it's essentially a paraffinic, naphtha cut material. So you could consider it as a blend stock for gasoline, but in and of itself, it doesn't meet the octane requirements.
Is it a low RVP?
That's a good question. We'll have to talk. I don't know what would be considered low and high, but we
Okay.
can talk to you
Then we'll
afterward.
talk.
Actually, the guy right next to you might be able to answer that while you wait. But he may not know either. Kelsey, yeah.
Are we
Thank
to
you,
the
Ed.
portion of the show where we're taking questions from other REG employees?
Thanks.
If so, Scott Hedrick, my good friend.
Yeah, so, thanks, Shelby. So I've actually heard the term renewable diesel quite a bit. I've not really heard the term renewable hydrocarbon diesel until working at REG. Certainly didn't hear the term, and I don't know if I can say it, isomerization until working at REG. I know there's a lot of other fuels out there that call itself renewable diesel. Does that mean everything out there is isomerized? What's the difference? What are we looking at?
That is a great question. So this is something that we try to educate people on every chance we get. So what a surprise that an REG employee would bring that up. So if you think of the starting materials, here are the molecules we start with. Like I said, this is a little bit different type of drawing than the others, but look at that molecule. That's in the 900 plus molecular weight. Very large molecule. That's a fat or an oil. Okay? When we get done making RHD, we have something in this size range. This is about a quarter that size. People who sell vegetable oils in particular, whether used or virgin vegetable oils, as diesel fuel blending components are selling these, okay? They're oxygenates, very large molecular weight. They might be liquid at room temperature if they're low enough in saturation, but they are not in the range of diesel fuel. After we've made RHD, or even after we make biodiesel out of it, we have reduced the size of the molecules, we've reduced the viscosity, we've improved the combustion properties dramatically. You can burn veg oil in a diesel engine, everyone knows that. That doesn't mean that the emissions coming out of the tailpipe are going to be all that desirable. As a matter of fact, they are undesirable in some ways. So burning veg oil is not the same as burning paraffinic hydrocarbons with a cetane of 75 plus. So keep that in mind. There are people that have pathways and are able to sell these with RINs, the veg oils, so it's not like they're going to disappear anytime soon. But be very aware that the reason we included that word hydrocarbon, the reason we added an extra word to renewable diesel, is to distinguish a hydrocarbon from a veg oil or a triglyceride. So these are not hydrocarbons. The bottom molecule there is a hydrocarbon. And you don't get the emissions and blending benefits with the triglycerides to the extent.
Can you comment on the relative cost of produced RHD derived from the same feedstocks versus biodiesel?
I probably can't comment specifically. I can say that you made an important caveat there, which was for the same feedstocks, because the majority of the cost of making biodiesel and the majority of the cost of making RHD are both feedstock costs. So that is consistent amongst the two products. Because the free fatty acids can be converted directly to your product fuel without additional technology, there can be an actual savings there. The plant itself is a little bit more expensive to build and operate because of the temperatures and pressures involved. So I really can't give you a satisfactory answer probably. But
Okay, thanks.
You can talk to me afterward.
yeah.
So I think we have time for one more question, and then we'll announce the gift card item. But Dave has agreed to stick around afterward, and Scott Fenwick, would you mind sticking around too to help answer questions? And I also noticed Nick Economides from Chevron's here. He's a fountain of knowledge too. Just ask him. So last question, please.
My question is toxicity. I noticed that your renewable diesel does not smell as strong as diesel fuel, but if you just put it on the ground, is it going to have the same toxicity as diesel?
So that is a good question. Strictly speaking, it is almost entirely paraffinic. Paraffins, mineral oil, Vaseline, petroleum paraffins are used in all sorts of care products that are even ingested by people or put on people's skin. So the paraffinic portion of it is non-toxic. It does have a very small amount of aromatics. The aromatics are typically the most hazardous portion of diesel fuel, of conventional petroleum diesel fuel. So it is significantly less toxic than diesel fuel than petroleum, but it would still be handled as a hydrocarbon diesel fuel material from a spill containment and cleanup standpoint, just because of the small amounts. Now that could vary. I'm not an expert on this from state to state or region to region, but you're correct that it doesn't have the smell because it doesn't have the aromatics. Aromatics actually got their name because you can smell them, but they are a certain category of molecule that have been associated with toxic effects and carcinogenic effects. So.
Great. Well, thank you very much, Dave. If we could get a round of applause for Dave. So the last order of business is to announce the gift card from those who have signed up for Biodiesel Connect. Is Marie Valentine in the room? Marie Valentine? If not, secondarily, Will Martin? Will? Do we have Marie? Okay, sorry, Will. Better luck next time. Thank you all very much. Enjoy the conference.